Well, it's not going to win me any awards for neatness, but it did get the resistance down to almost exactly 7 mega ohms. So now I'm going to power this meter back up and see if it fixed the problem. If it did, I'll look around online for a more reasonable replacement resistor than this assembly here. Okay, crazy as it may look, that mess of resistors actually did help out a lot. Right now I've got the power supply on 50, digital meters reading 50, and this guy's reading 50. I'll crank this down, and all 3 meters are moving in unison. And get down to about 10, and across the board, 10, 10, 10. So, it's just one of the joys of these old meters is you may have some of those precision parts that have drifted off of value, and you're going to need to try to tweak them to get them back in tolerance if you want to make precise measurements. Now, important thing to keep in mind is when you do alignment work, like I'm going to be doing with this meter, you're just going to be looking for a peak value. So you're going to be watching as the meter swings. You don't care about the precise value that's on the meter. So for the time being, I'm going to take those resistors out while I look around to try to find a suitable replacement. But don't let that scare you off of using one of these, or if yours isn't quite calibrated perfectly. It's still perfectly usable for doing radio alignment work. Now I'm using a little bit of Novus number 2 scratch remover to see if I can get this faceplate looking any better. Simply squirt it on, take a rag, and rub circles like waxing a car, let it dry to a haze, and then buff it out. And there we go. Not too bad. A few of the deeper scratches are still slightly visible, but otherwise cleaned up nicely. As a wrap up to this video, I thought it'd be interesting to take a look at the insides of all of these meters side by side. Here's the ICO 232, here's the RCA VoltOhmyst, here's the RCA Senior VoltOhmyst, and here's the Hewlett-Packard 410C. These 3 all have a lot in common. They all have a little AC power transformer. They all have a rectifier, selenium, and this has a little silicon diode. Then they all have a small filter capacitor. This one's buried underneath. And here it is on this guy, and I replaced it on this one. And they all have that battery D cell. This one originally had a C cell, but I put in a AA because I didn't have a C cell on hand, and a D cell. And they all have the same tubes, 6AL5, 12AU7. And they all have very similar features. They all have a very similar voltage range, and both measure both AC peak-to-peak volts and AC RMS volts and resistance. However, none of these measure current. I don't think I mentioned that, but this guy can measure current. So if you want to measure DC or AC current, either you need to get a special, more expensive meter like this, or pull out your modern meter. Now as for this Hewlett-Packard 410C, as you can see, it's considerably more complex inside. How it works is beyond the scope of this video, but briefly, here's the more massive and complex power supply. The amplifier is on this board. The real magic is inside of this plastic box here, where there are a couple optical cells that form part of a chopper stabilized amplifier. There is one tube in this, but newer versions don't even have that. It's all transistorized. And then here are all the calibration controls. I've already gotten some advice on what might be wrong with this. There are some very helpful people online who know a lot more about these than I do, and they've already given me some great advice. including how to fabricate my own AC probe using some modern silicon diodes in place of this impossible to find vacuum tube. So look for that restoration series upcoming in the near future. So remember, things to look for when you're shopping around for a VTVM. Get one that looks good cosmetically, one that the seller claims is working, one that has good probes, and when you do get it, open it up, check these batteries. Quite often they're old and leaky and you get corrosion like on this one. You might want to replace the selenium rectifier with a modern silicon diode like a 1N4007. Check the two tubes, download the documentation online, go through the calibration procedure, and hopefully you'll have a good working meter.